It closed, so what it did was it sent the 24 volts from R to W, came over here, which common was already made because it's always there. Closed the relay to give the line voltage to here. The neutral for the 120 is already there. All we're doing is controlling the hot leg. That's all we're ever doing, is only controlling the hot leg on everything. We're controlling the hot leg for the condenser, we're controlling the hot leg for the blower and for the heat, okay? So there's the heat. If we wanted to turn on the fan, there's a lot more to this, but that's all for explanation we can go through later. But you turn on the fan, there's the fan, we turn the fan off. We can change it to cool. Now in cool, the thermostat controls the blower and the condenser, right? Mm-hmm. So what should it do? It should turn on the blower and the condenser, right? But we are having problems with the thermostat. I need to put a different thermostat on there. That thing's crap.
Should have been a train.
It's just a crappy freaking thermostat. You got your 24 volts. This is your ground. This is your hot leg, right? Well, the hot leg comes to the thermostat, and all it does is it either closes to Y, making Y R to bring on the condenser, or it goes to G, making G R to turn on the blower, or it goes to W, making WR to turn on the heat. And so when it comes to Y, before it comes onto the condenser, that's where all your safety controls would be. So this is the schematic symbol for a high pressure switch. This is the schematic symbol for a low pressure switch. This is the schematic symbol for a high temperature switch, or like a thermal overload inside of a compressor. If any one of these opened, it breaks that, which is now Y, before it can get there to close that contactor. But since the thermostat isn't working, we're gonna cheat. This is what we do when we think a thermostat's bad, right? We bypass the thermostat with these crappy freaking. You know what? I'm just gonna hold it on. Oh, they're magnetic. Sweet. That's what the thermostat does. That's all it does, is closes R to Y to turn on the condenser. But the thermostat, oh, now it's freaking working. That's ridiculous. Okay, so like I said, the thermostat itself is what controls the blower for cooling. So inside the thermostat, when it calls for cooling, it actually closes Y and G together. When you set it to cool, it closes Y and G together. When you turn the temperature down to where it would call for cooling, then it closes R to those two. That's why they both came on. On heating mode, it doesn't. On heating mode, all it does is it turns on the heat, and then it's the furnace itself that determines when to turn the fan on, whether it's a time sequence or it's reading the temperature. But it's creating a delay because you want to actually get that heat exchanger warm before you start blowing air over it. Otherwise, you're blowing around cold air when people want heat. The other thing a thermostat will do is when it's satisfied, it'll shut off the condenser first, and then slightly thereafter, the fan will shut off. Now, if it was a heat pump, it would bring on the fan. Anytime the condenser comes on, it'll bring on the fan. So in heat pump mode, it would also energize the relay to bring on the blower. So like now, I'm gonna turn the temperature up.
At thermostat.
See how it had a delay? Turn it to heat. It's working on heat, but cooling for some reason is an old thermostat I just saw sitting back there. That's why we used it.
Yeah, sweet.
So there's the heat. And then this way you can check with your meter. You can check what a normally open switch that has power on it is. Like right now you're running heat and you have power on it. That's why you're not showing any voltage, because you're reading one leg. But if you go like this is where everybody gets confused when they're learning how to read a meter.
Yeah, my leads are so dumb. Probably do that.
Everybody gets confused because if you read the one leg, remember this is one leg, this is the other leg. So first you have to verify that you actually have power coming from the transformer. Mm-hmm. And we do. We've got 27 volts is what it says. Okay. Now if I want to see the one leg, if it's open, I'll go like right now it says the heat is running, right? So yellow, which would be our air conditioning, shows 27 volts because it's the same leg. That voltage that's here present right here on R is now going through the meter all the way to here, going through the coil, coming back through ground. That's how we're getting that path and we're reading that voltage. But that doesn't mean that there's voltage at Y. If you wanted to know if there's actually voltage at Y a different way when there's power on, you just complete the circuit by going directly to ground. And now it shows 0. But if I go to R, there it has voltage. So what's running? Heat. So to ground, I should read voltage, and I am. But if I, now remember, all R did was it closed to here. You saw me take the jumper wire and put it on there, right? So if I go W to R, which is actually running right now, that's closed this relay to bring this on, I don't read any voltage. Why not? Because it's basically just like going like this. I'm not going to read any voltage. Even if there's voltage there, I'm not going to read it. Now, like this one right here, this is high voltage right here. So the contactor's open, making a little electrical circuit there. But if you look at the meter, we're reading voltage across there. Got voltage here, nothing here. Oh.
Hey.